Today we're told humans are smarter than our ancestors even just 100 years ago. But what's interesting is that anthropologists have found that for the last 10,000 years, our brains have actually been shrinking. Although the brain is only 2% of your body weight, it uses 20% of your energy. So what happened 10,000 years ago that changed the trajectory of our brains? And does this mean that we're getting dumber? For millions of years of our evolution, our brains have been rapidly growing with the rise of our rapidly growing meat consumption. The more we relied on energy-dense animal foods, the smaller our gut shrank and the bigger our brains became. This is referred to as the expensive tissue hypothesis. Instead of evolving large fangs, claws, or strength, humans evolved something far more powerful. So, to understand why this really matters, and why the brain is shrinking, we need to understand why the brain truly grew in the first place. It seems to be more common knowledge nowadays that exercise is not only beneficial for the body, but also the brain. In the book Spark by John Ratey, he breaks down a long list of benefits of exercise, from growing neurons, which is referred to as neurogenesis, to protecting against mental degeneration and increasing brain-derived neurotrophic factor, which is often called miracle-grow for the brain. But why is movement so beneficial for humans? Sure, people will state the biochemistry and the increase and decrease in certain hormones, but from a first principles perspective, there is one core reason. Exercise mimics hunting. One of the main reasons why our brains grew and are so big relative to other animals is because we are apex predators. People will say we don't have big teeth and claws like a lion, but that's actually the point. Each carnivore has its own niche, meaning its own way of hunting and usually a preferred type of animal. Humans evolved our brains as a weapon instead of, say, claws, for example. Our ability to plan, problem solve, create tools, and communicate socially is our version of claws, stemming from our brains. This also makes sense why we prioritize megafauna, as they are very high in fat and requires complex planning to hunt. But there are times when we can actually work against our biology for our own gain. For example, if I'm trying to build muscle, I intentionally push my muscle past the point that they are comfortable in an attempt to push my weightlifting sets to absolute failure. This is essentially the core philosophy of high-intensity training. Henneman's size principle states that muscle fibers are recruited from smallest to largest depending on the force placed upon them. Because building muscle is energy expensive, it is actually one of the last things that your body wants to do from an evolutionary perspective. Therefore, there is not only a strong physiological, but also a strong psychological struggle when pushing your muscles to absolute failure in the gym. This creates a hormetic effect, meaning a short-term stressor can actually create a beneficial state in the body by forcing an adaptation that would not normally happen otherwise. But food and diet, on the other hand, is a whole different story. The direct fuel for our bodies should be one of the last places that we induce a hormetic effect with our bodies, especially given that food is the larger factor that determines our metabolic state, thus having a massive influence on our brains. Research led by Roger Seymour shows how crucial efficient energy utilization was for our ancestors. Over the millions of years of evolution for humans, our brains evolved to become larger and more complex, demanding significantly more energy and oxygen. Over this time, our brain size increased by a drastic 3.5 times, while blood flow increased by 6 times. This was a result of evolutionary pressures to maximize our brain's ability to think and solve complex problems, specifically when it came to hunting. But roughly 10,000 years ago, this all changed. This is when the agricultural revolution started, which introduced significantly more plant matter into our diet relative to meat. And in more recent times, with the Industrial Revolution accelerating the processing and the availability of these plants, it's no surprise that disease is skyrocketing. Now, I could go into the nuance of why plants are suboptimal for humans, or why highly processed food is so bad for us, which I'm sure you already know, but from a first principles perspective, all we are doing is straying farther and farther away from what our biology has evolved to expect. Roughly speaking, if you were to break the entire human evolution down into 24 hours, agriculture was only introduced in the last hour, and the Industrial Revolution was only introduced a few seconds ago, meaning we still have a near identical biology to a human roughly 300,000 years ago. For the majority of this time, humans ate mostly fatty meat from large ruminant animals, meaning our primary source of energy was fat, not carbohydrates. When the body relies on fat, this creates a drastically different metabolic state than relying on carbohydrates. So what happens when carbs aren't an option and the body is now running on fat? When carbohydrates are drastically reduced or eliminated, your body now uses stored fat or fat from your diet as fuel. Ketogenesis is when these fats are broken down into something called ketones. Often these ketone bodies are referred to as an alternative fuel source, as these are used to fuel the tissues of the body as well as the brain instead of strictly glucose. But the only reason ketosis or ketones are thought of as an alternative fuel source is because modern diets prioritize carbohydrates, which all break down into glucose in the body. This is a more reactive fuel than fat via the formation of advanced glycation end products or AGEs, so the body must rely on this state of metabolism constantly. But in reality, for most of our evolution, we were relying on very minimal or essentially zero carbohydrates from the diet, and a ketogenic-like state is actually the baseline metabolic state of many animals, especially carnivores. So what if this alternative fuel source is actually our brain's preferred method of fuel? For example, beta-hydroxybutyrate or BHB, which is one of the primary ketones produced during ketosis. This ketone body goes beyond just fueling the brain efficiently. It also has many neuroprotective benefits. BHB also enhances brain plasticity and can increase the levels of brain-derived neurotrophic factor, or BDNF. Interestingly, when it comes to exercise, this wasn't well known what caused the increase in BDNF until research came out led by Dr. Sam Sleeman, explicitly showing how exercise significantly increased BDNF through the production of BHB. Therefore, it is no surprise that there is a synergistic effect when we align both what we eat and how we move closer to what our ancestors experienced. And not only is BHB providing a cleaner, more stable source of energy, but it's also protecting the brain from degeneration. But it's not just the fact that your brain prefers running on ketones, it's also about what comes with it. Your brain thrives on the nutrients found in meat. Creatine, B12, DHA, choline, iron, zinc, all essential for focus, memory, and mental energy. And it's not just vitamins and minerals. Cholesterol and saturated fat are just as important. After all, your brain is mostly fat. So given our brains not only grew in size, but demanded drastically more blood flow and oxygen, eating fatty meat as a primary fuel, tied with this metabolic state, was not only preferential, but fully necessary for our brains to grow. But where does this leave us today? Does it even matter that our brains are shrinking? Sure, we may seem smarter than those even just 100 years ago, based on standardized testing, which has little to do with our brain size. But even this seems to be fleeting nowadays. Because not only have we outsourced our hunting and eating, leading to less nutrient-dense foods and less movement, but we also seem to be outsourcing our thinking. With the rise of large language models like ChatGPT, many people are now outsourcing the very thing that makes us human in the first place, our ability to think critically. Sure, these tools may still have their places, but only if they are used properly as a tool, and even then, I think this could be very risky. This study found that those that rely on models like ChatGPT for writing essays see a drastic drop in brain engagement, deep thinking, and memory recall. We've outsourced our hunting or movement to farming, we've outsourced our food quality to the Industrial Revolution, and now we've outsourced our thinking to large language models. So what do we do about this? Well, obviously our world looks nothing like it did tens of thousands of years ago. But that doesn't mean that there aren't ways to combat this. The best thing we can do for our brains is to mimic the circumstances that our biology has come to expect. Exercise can mimic hunting, eating nutrient-dense animal foods gives us our proper fuel, and intentionally challenging yourself intellectually by reading books or practicing articulating the things that you have learned can drastically reduce the regression of our brain processing. The same goes for socializing. So why are our brains shrinking? Well, almost all of it comes from misaligning our modern lifestyle and habits with what our biology has come to expect over the last hundreds of thousands or even millions of years. Peak performance comes from aligning modern life with how our biology evolved. So if you want these 7 core principles I follow to align our modern lives with what our biology truly expects, you can find these 7 principles to optimize your biology in the description below.